9 of May 2022, Lobster Island was eventually hit by a massive meteor which then caused radiation to occur, and due to this, the citizens were immediately evacuated. Many people are in a confusion on what other actions would the authorities take, as the radiation has many side effects. Let's hear out from Hafiz for a brief explanation regarding this issue.
So the question is, how can the radiation affect Lobster Island? As a member of the Science Advisory Group of the island, I will explain to you about this. So one of the effects is that the radiation can cause major health issues to the citizens if they are caught in the radioactive radius. For instance, the atoms in the living cells, or in this case, the human cells, can be irradiated by ionizing radiation, which damages the DNA of the cells. Acute radiation syndrome, often known as radiation sickness, and cutaneous radiation injuries, which are burns and injuries to the skin, to our skin, can also result from severe radiation exposure. Another possibility is long-term health effects such as cancer, cardiovascular conditions, anemia, leukemia, and hemorrhages. Despite the health risks, the radiation can also affect the nature and environment of Lobster Island. If the situation is not handled, soil pollution may result from the improper disposal of the radioactive waste, which can seriously contaminate the soil. This form of waste contains radioactive material, which may combine with soil elements and make the soil extremely poisonous and infertile.
So first and foremost, these are the problems that we have to solve in order to rescue Lobster Island. The first problem is what radioisotopes is present in the meteor. Then the time taken for the radioisotopes quantity to decline by half, and the ability to achieve a safe concentration level. Meanwhile, we also need to use any kind of technique may be used to identify the radioisotope. As we all know, the meteor impact happened on the 9th of May 2022. The event caused the mayor to advise the science advisor team to create a rehabilitation plan. Once the concentration of radioactive material in the waterbed reaches a safe level of 350 parts per billion, the island can be restored. Next, I will be discussing about the objective, as you can see here. So, the meteor's radioactive component was identified, and its radioactive concentration was conducted and analyzed. Next, the leader of the science advisor team will present the rehabilitation plan to the mayor and the populace. After that, we can determine the meteor's radioactive component and calculate the half-life of the radioisotope. And then we can examine the kinetics of the decay rate, including determining the integrated rate law. After the calculation has been checked and finalized, we can select the exact time frame for the island's recovery.
Finally you're here. Can I take a seat? So there's been a huge catastrophe in the Lobster Island. I need you to immediately recruit a team to solve this problem.
Don't worry, Mr. Mugu. I already have my team to solve this problem.
Okay, so who are they?
Okay, I have recruited the best team with me. They are the best fellow scientists who are Mr. Syed, Mr. Mikael, and Mr. Hafiz.
Alright, so what are the plans for you that you have planned to solve this problem?
Okay, to solve this problem, my plan is the first step. We must collect the samples of the chemicals in order to continuously monitor and experiment to determine the isotope, and then we should calculate how long it will take for the isotope to disintegrate into parts that contain less dangerous radiation, about 350 ppb radioactivity in the waterbed.
Okay.
So, Mr. Ugo, I need you to approve this plan.
Yeah, sure.
Okay, thank you.
So I wish you and your team best of luck. I hope to hear you from soon.
Okay, trust our team.
Yeah, sure.
Thank you. Okay, so this is the water sample of the Lobster Island.
After we have determined the element from the mass spectrometer, which is thorium-227, and the concentration is 95 ppm, we need to convert the concentration to ppb, which is we multiply with 1000, so we will get 95,000 ppb. And then the element have let it decay for 20 days. The concentration for each 4 days have been recorded until it reached day 20. When plotting the concentration versus time on a graph, the curve typically shows an exponential decay for a first-order reaction. Therefore, we need to use the first-order reaction integrated rate law to find the rate constant that leads to determine the half-life and the time taken to rehabilitate Lobster Island.
So, after my fellow scientists already carried out the experiment using mass spectrometer, they already identified the elements in the meteor, which is thorium-227, and the initial mass of the element. Therefore, I can identify that this reaction will use the integrated rate law of first order reaction. Before we get the formula, we need to use the differential rate law of first order reaction, where rate represents the rate of reaction, K represents the rate constant, and A represents the concentration of reactant. So, to get the integrated formula, first we need to differentiate this formula, differentiate with respect to time. So this is the formula of differential rate law. After that, we can separate the variables. We can put the concentration on one side and the time on the other side. After we separate the variables, we can integrate it with our boundaries of time equal to 0 and the time equal to t. After we integrate both sides, we get a new equation, which is ln concentration at a given time subtract by ln concentration at initial time equal to rate constant divided by time. After we rearrange it, we get the final equation equal to ln concentration at given time equal to rate constant divided by time plus ln concentration at initial time. Thus, this is the integrated rate law for first order reaction. Therefore, we can use this formula to find the initial concentration at given time with the rate constant. Okay, after we already get the integrated rate law for first order reaction, the next thing we need to find is the rate constant. So, from the given graph have been plotted and the table, we can see the slope of the graph is equal to rate constant. Therefore, we can take any points given in the graph to find the rate constant. So, the equation of the rate constant we can use is this. Therefore, we just take any points in the graph, we can use the data to find the value of rate constant. Therefore, the rate constant for this reaction is equal to 0.036 per days. Okay, after we already get the rate constant, which is equal to 0.036 per days, we can find the half-life for the reaction using this following formula, where half-life equal to ln 2 divided by rate constant. Therefore, we just substitute the value of rate constant into this equation and we get the value of half-life, which is 19.25 days or approximately 20 days for one half-life. Okay, after we find the half-life for the reaction, next we need to find the time for the Lobster Island to be fully recovered and rehabilitated from the radioactive. Therefore, we can use the integrated rate law of first order reaction to find the time to calculate the estimated date. Therefore, we just rearrange the equation to find the time and we plug in all the data that we have got from the graph and the table. We can find the time which is equal to 155.65 or approximately 156 days for the Lobster Island to be fully rehabilitated. Therefore, from start of the meteor strike the Lobster Island to 156 days later, we can give the estimated date for the Lobster Island to be fully recovered is on 12 October 2022.
So, we finally come to the conclusion and everyone have done their part. So, we already get our estimated date that our Lobster Island will be fully rehabilitated, which is 12 October 2022. So, go everyone, and now it's time for me to meet the mayor at once. Go everyone. Mr. Mugu, I have good news for you.
Yeah, thanks.
Okay. Okay. Our team has done our job, and we have concluded that after 156 days, on the 12th October 2022, our Lexington Island will be radioactive free and fully rehabilitated. So the community can go back to their normal life and do their routine activities there.
Thank you very much. You have done a very great job, you and your team, Mr. Azib. I am very happy that our community can go back to their basic life. Once again, thank you very much.
Okay. My pleasure, sir.
Yeah. See you soon.
Okay.
Good morning everyone. This is Musa here reporting live on Lobster Island. Today is the reopening of the Lobster Island. It has been 156 days since the island has been struck by a meteor. The radioactive isotope was determined to be thorium-227. They also determined that today, 12 October 2022, the island is now safe and free from rehabilitation for thorium-227 to completely decay from initial concentration of 95 ppm to 350 ppb.